Hello? Yeah, the introduction is already over. So I'll module. Module. I'll introduce you to Apache Lens. It's a data analytics platform. So we have seen processing platform earlier, that is Falcon. So this is only to do with the analytics, no processing. So first I'll give you the evolution of typical data analysis that happens at an enterprise, and then we'll introduce Lens, and then I'll walk you through the Lens architecture, and then I'll give a brief introduction to the OLAP data model that is introduced in Lens, and then we'll give you a demo. I'll spend more time on the demo maybe so that you can understand, then I'll discuss the roadmap. So if we look at a typical enterprise when it just starts, right? So when they have reporting requirements and what is happening in their business, so they'll start. Okay, we'll put our data in RDBMS and then run reports out of it, right? So that is how you will see what is happening in your company, and then you'll put it in RDBMS, and you'll start putting aggregated and materialized views also in the DB. And maybe it would go to few TBs. After that, that can't scale. When your business grows, your data will be huge, and RDBMS solution won't work. So we look at actually the challenges of RDBMS. So when the data grows more than few TBs, the data loading into the DB itself takes more than 24 hours. This is from the perspective of, these numbers are mainly from InMovie's life, like how it went through. Data loading itself is taking around like 24 hours, and you could do analysis only up to 3 dimensions. If it is more than that, the DB won't respond, you will just wait. And there is one heavy query that is churning of your DB, then other queries can't run, they will be just waiting for the resources. And then there will be new requirements coming in your business, and your system won't cope up with that. So then what do? So then the generation 2 comes. Go for a columnar DB, which can scale more than few TBs, right? So what you can do in columnar DB, you can store it as a warehouse. So you'll take data from your RDBMS, the transactional data, summarize them, keep smaller sets, smaller data in summarized form in your columnar DB, and run reports out of that instead of your transactional data. Right? Then you can build rich dashboards on top of it, and columnar DBs respond fast, and that will work for your reporting. And then what are the challenges again? So there are still challenges here with data growth. So if you have 1 billion requests per day, columnar DB is not going to scale to that. And then if your data grows, actually if you have to grow your columnar DB, they are usually licensed, there is no open source. So you will have to spend more money on the software itself. And then the data modeling and ETL cycles to load into your columnar DB will also take long when the data grows more than that. And then, so even in a columnar DB, if you have to look across more than tens of dimensions, you can't look at it, because again the queries there will be taking time when you're actually looking at in more than few cuts. So earlier that was 3, here it could be few tens. So so then so at InMovie we use InfoBright. The other columnar DBs like Vertica as well, so which are licensed, you'll have to buy the DB from them. They'll charge for every TB. Like if you have 5 TB, they'll charge so much. If your data increases, say 10 TB, they'll be charging differently.
So there is no issues in terms of the data growth. It's just the cost part with columnar DB.
No.
Because Vertica, there is no issues when you have a lot of data growth. But definitely I
Sure. The ETL cycles, so Vertica I don't have experience with, but I'm not sure ETL cycles are like good there. Yeah.
Yeah, cost will definitely go, but like Vertica, you typically don't grow it vertically. You typically do that horizontally. Right? So scalability should not be an issue. Definitely it will be expensive.
Yeah, cost, that is the factor.
Yeah.
Cost and for big data kind of lot of this. But cost is very good.
Yeah.
Yeah. So then the third generation, okay, use both. Use Hadoop and Columnar DB. So use Columnar DB for reporting and then Hadoop for your analysis. So again, Columnar DB is used for summarized, small and summarized data, and then build dashboards on top. And keep your granular data in Hadoop, hundreds of TBs and petabytes. Then do ad hoc analysis on top of it. Right? So this is the usual pattern in companies. So you have reporting as separate and ad hoc analysis on Hadoop. So what are the challenges with the third one? So there are two lines of independent data warehouse systems growing in your company, and there can be data discrepancies if ETLs are not doing the same thing on both lines. So though that should not be there, but there can be one pipeline that didn't do correctly, and those should be uncovered. So the data that is loaded into warehouse or Hadoop, wherever it went wrong, should be uncovered. And then there is schema management, more about if you are adding more fields to be queried to your reports, then you need to go change two different systems independently and then make them queryable. And then so when a user comes, he doesn't know which system to go and actually query for. It's the same data available in both the places, and he has to go for reporting into one system, and ad hoc analysis he has to go into another system, and he has to learn a different API for each system and different language for each system if it is talking differently. And and the end user here is usually not a developer. Will be usually the business analyst who wants to run some query and see actually what is happening in the business, and wants to know more details, doing some ad hoc analysis why that happened, right? So if he has to go to a different system for ad hoc analysis, that makes the job becomes more difficult for him in that. And if one user doesn't know actually there is such a system like where the small and summarized data is there, where he can go query it, and if he launches everything on say Hadoop, so where the data is directly available, he is not taking it, but everything is like getting aggregated from say raw data, and like that is inefficient utilization of whatever your data is already summarized and kept, right? So they don't know because they don't know which system to go. So these were few challenges that we are facing at InMobi, that there are two different reporting systems growing in the company, and InMobi has many analysts because it is a company where it provides marketplace. So there are advertisers coming in, publishers coming in, and there are like campaign managers helping advertisers, there are other people helping publishers, and they want to report what is happening to their business every day, and they'll have to go to these systems almost every day. So that is when Apache Lens was thought of, so it solves the problem whatever we have seen in generation 3. It's still, the data is in both Hadoop and Columnar warehouse, but it wants to address the challenges that are that people are facing with generation 3. So it gives a platform to enable actually multi-dimensional queries in a unified way over data sets stored in multiple warehouses. And it also gives OLAP cube abstraction on top of your data. So when you look at data in Hadoop, it is, when you just look at it HDFS, it is all files. And there is some way to give it structured data in Hive where it gives table notion to files and HDFS with some schema associated to it. But actually the underlying data in HDFS is actually a warehouse where there are different fact tables rolled at different frequency and different dimensions are rolled up, dropped, and measures are rolled up, right? So actually that is a OLAP cube. I am assuming like people understand the OLAP concepts and data warehouse. So I am not going into details of what is OLAP data warehouse. So, but if you have any question, I can take it. So it introduces OLAP cube abstraction on top of both the storages, on top of Hadoop as well as the traditional warehouse, and gives a single unified abstraction there. And then so where is the data, what is the schema of the data, and where is it available? It gives a single metadata layer for that. And then gives single access, single querying layer for both the stores in a single place, integrating both Hive and other traditional warehouses. So more on Lens. So actually Lens itself doesn't run the query. It's only actually the as it is named aptly, it is simply the lens that is passing through, and it is actually happening on the below engines like Hive or on the DB that wherever the data is present. So the queries actually run on the individual engines that are running, and Lens itself doesn't have any engine. But yeah, so it gives a single catalog management so that all applications talk the same language, same schema. So it also provides query analytics on top of the queries that are running in your system. That will help you actually find what are your hot data sets. These are the fields actually people are interested out of all the data that is stored in your warehouse. For example, revenue would be the one that everyone queries, and not something very low that only one or two guys in data science query, right? So it will be able to give you what are the hot data sets that are queried in your company from the analytics. Then it also gives abstractions so that you can easily experiment with newer systems like Redshift or Spark or Thales or any other system that you want to experiment and compare. Okay. So before going further, so just summarizing the analytics use cases. So we have reporting queries where we need to generate a report that is usually fixed and generated daily or monthly or quarterly, and that report is usually fixed and won't change very often. And there are ad hoc queries, which as the name says, it is ad hoc. We don't know the user intention. He wants to go find out what is happening. It's on the more debugging side. So some of the ad hoc queries can be interactive or batch. And there can be scheduled queries. Scheduled queries are the same query you want to run every week Monday morning or first of every month. So you want to run that report, and that should come to your email. Right? The other use case of analytics is actually infer more insights of your data through ML algorithms. So Lens want to unify the use cases in a single platform, and you can use underlying capabilities and plug in underlying capabilities, experiment with them, and so when we see architecture, we'll see more. So this just discussed. I'll spend some more time. So if we put the IO required for a query and the response time in the graph. So these are the canned queries which require like less IO scan and immediate response time. So so the canned queries here are usually the report queries, where usually the report is fixed. The number of fields that you query every day is fixed, and those if they can come from the warehouse and summarized and kept and answered from warehouse, those come very fast. And some of the queries can come from warehouse itself, which can be ad hoc, or which require like less IO. If it requires more IO, if you are running a query for data that is spanning over a month or a quarter, it may not come immediately. It can span say an hour, or if you are running in a Hadoop cluster, it has to wait for other jobs in your queue, get scheduled, run it, and then give you a report. So that can take time. So when your use cases are like this, so usually this bottom corner is like answered from warehouse, the traditional warehouse, and this one is like answered from Hadoop. This can go anywhere. Like some can go to Hadoop, or some can go to warehouse. Before I go into architecture, are there any questions? It's fine. Okay, so this is simple architecture. So we'll maybe go bottom up. So we have like all the data stores where the data is lying. So we have HDFS, HBase, Columnar DB, or S3, or Redshift, or any other source where data can be stored, say in a tabular format. So HDFS is put here because there is already table structure that can be imposed on HDFS data through Hive. But wherever the data can be stored in a tabular format, that can be a store here. And then there can be execution engines which can talk to these stores. Like for example, Hive can talk to HDFS, and Hive can talk to HBase as well. Hive can talk to S3 as well. JDBC can talk to Columnar warehouse, Redshift, or Spark SQL can talk to HDFS, S3. Right. So so the only relation between so these are called drivers, inlets. This is like the connector that you write for each. So these are called drivers, which uses the underlying execution environment itself. And the only relation between the data store and the driver is the driver specifies what all storages it can work on. That's the only relation, otherwise they are not related at all. So Hive will say that these are the storages I can work on, and JDBC will say these are the storages I can work on. And then so Lens server integrates to each of these execution engines through the driver API. Driver API is very simple. It looks it has simple methods like, okay, give me the cost of the query, and then do an explain and execute and fetch result, cancel the query. So we can look at it if you want to, but yeah, so it is as simple as like implement those methods, then your driver can be plugged in. And then so there is single entity Lens server which has its metastore backed up by actually Hive metastore itself, and the OLAP queue definition is actually stored in the Hive metastore. And then Lens server itself provides REST API for querying your data and doing schema updates for your data. And there are clients built for CLI, Java client, and JDBC. There can be more applications built on top of the REST API.
Let's say I have to connect some of the reporting tools that are through Hive using ODBC connections.
Okay, so it can, if it can connect through JDBC client, and I'm using, I'm saying JDBC here.
No, but like that uses a ODBC connection. It doesn't interface to a JDBC connection. So typically when you connect these reporting tools or something with, let's say, Hive, you typically interact through an ODBC connection.
That's JDBC connection.
Typically I have tried out Tableau that does not support JDBC. Connect with JDBC?
Yeah. Yeah.
Okay, but it is, okay, we need to use some kind of
So JDBC client should work for that. So I'll spend some time on the OLAP data model, then we'll go to the demo. So yeah, so in Lens, storage is a first class construct. So you provide a name to your storage and maybe the endpoint of where it is. There is cube which has measures, dimensions. Dimensions, I will call it as actually dim attributes because there is already a mention. So there are measures. Measures are something that can be measured. So like when an event happens, right? So and when series of events happen, what you'll do is you'll measure something out of it than just keeping it that way. So you'll say, okay, number of clicks happened is so much, or number of revenue burnt is so much. The value of revenue burnt is so much. So there will be something that you measure over the time of over your events that have happened and keep the measures in your warehouse so that those are queryable. We'll see example, then you might understand more. And then attributes are something upon which the measure is measured. For example, on this, in case of InMobi, on this phone, so many clicks happened. On this phone, on this location, so many clicks happened. So there can be many attributes that are associated to your measure, right? And yeah, so the cube consists of measures and dimensions. And actual data, your event data is actually stored in a say fact table. Right, the table here is actually the table definition, which says these are the columns of the table, and when you associate a storage to it, it is the physical table, underlying physical table for that. And there is a derived cube out of a cube, which gives a view of the view of some of the measures, and subset of measures and attributes can be put in a derived cube, so that you give a view to the user that only these fields are together. And dimension is data associated to more to a domain. For example, handset is one domain where one dimension where all the details about the handset are kept. Like this is the model, this is the color, these are all the available colors, this is available in all these countries. So you can keep information about that. But this data is not event data. It's not that an event that has occurred. This is data about a product, right? So this data is something that will usually change very slowly. Like there can be new models coming or new colors added, new countries that it is getting adopted into, but it will not change say every second or every hour. Yeah, there can be some data which changes every hour, but not everything will change so frequently as your event. It's not events. It's about the domain, right? So those are called dimension. So and the tables corresponding to them is dimension table. So if you summarize the data model, so we have cube which can actually relate to a dimension. So in the cube we have fact tables, right? So fact table usually will not keep everything about your attribute. You will only keep an ID which will fall into this dimension and get more details about that. For example, handset ID you will keep against the revenue that is measured, and handset ID is actually a primary key in this dimension. right? And dimension itself can have one more dimension linked to. And fact tables belong to the cube. Cube has fact tables. A fact table is associated to a storage. Dimension tables belong to dimension. Dimension table has dimension tables. Dimension table is associated to a storage. So it gives simple SQL like language for querying this. So there is a prefix as cube. So if we ignore that, everything else is like SQL, and there is a filter in a where condition where you can give the time range. So time range is a must if you are querying the fact data. Okay. So we look at the demo. So I am looking at simple e-commerce example here. We say we have sales queue, and which has all the facts, and it is related to, it has the dimensions as like product and customer and city. So sales itself is associated with city, and customer himself is again associated with the city, right? So in the example model, maybe I'll describe this and then show you how it is done. So this sales queue which has a raw fact which is present on HDFS, and there is an aggregate fact that is built which is on HDFS and DB, and there is aggregate fact 2 which is built and put on HDFS and also the DB. And there is customer table which is present on both stores. There is product table which is present on both stores. City table is present on HDFS, and there is a subset of city table that is kept on DB. So this I wanted to illustrate the subset feature, so I kept it that way. So let me quickly take you to the demo. This is visible? So I am just starting the server. Actually, before that comes up, let me show you the so Hive. It is working on like temp warehouse here, and I don't have any configuration, so it is running with like local mode, local Hive server and local job runner. So the JDBC driver is running with HSQL DB, which is present in this some temp in MySQL mode, and there are it says that okay, the supported storages for me is like MyDB. Right, if we look at the Hive one, I forgot to show you. So this says okay, I can work on local storage and cluster storage. This is so client. This is running on my laptop. Everything is like local. So examples have like sample metastore and populate and some run queries. So we'll just we'll create sample metastore. Before that, I am just opening the sales cube definition. Yeah. So if you look at the sales cube definition here, it has measures like okay, unit sales, so type big int, and then it is aggregated as sum when it is aggregated in the facts. and the display string is like unit space sales, and it should be formatted with this. And then the store cost has a start time from when on we actually started populating the store cost. And then there is there are expressions. If you see here, there is like profit, which is like store sales minus store cost. And there is promotion sales, which is a complicated expression, like if case when promotion head is 0, it is actually 0, otherwise pick store sales. So you can write expression like this as well. And then there are attributes which are all IDs here with respect to the foreign key corresponding to them. And then there are some chain columns, like customer city is actually coming from customer city chain. I'll show you the chain definition here. So customer details is the chain name where it says like sales customer ID is customer ID. The relationship between customer and sales is given here. So why do we need to define it as a chain is, I will show you one more example. Yeah. So if you, so customer city is defined as separate chain where you get the city corresponding to the customer. So there is a customer city directly available in the fact, then join with city, otherwise join with customer and then join with customer to city ID to city. So at runtime it can pick which path to choose depending on the storage. Like if the fact corresponding to the eligible fact that doesn't have the customer city ID, then it can pick this longer path, actually join with the customer table, get the city ID and get the city table and give you. And the city itself is not just customer city that you would keep, you would have kept like delivery city also in your sales, like it is actually where is it delivered. So the delivery city ID is joined with city and this is delivery city dot something that you can do. So yeah, this is populated. So it is adding some data to the tables that are created. So I'll just open up the CLI. So if we look at actually one of the aggregated facts definition, right? So it has kept few columns, not everything that is defined under the cube is in a fact. So it has put few attributes and a subset of measures. Not all the measures are kept in this aggregate. So like sales and maybe maximum line item price and discount is put, but not everything else. Because yeah, so in this example maybe we found that these are the frequently queried, and the storage tables corresponding to this is okay, they are actually updated hourly and daily and are partitioned on process, and they are processed at some time and they are partitioned on order time and delivery time. So you have kept your data and okay, this was the order, this was the delivery time, and this is the data corresponding to it. And then so this is in local, right? So the daily update one is kept in DB, MyDB, and it says okay, this is stored by a storage handler, DB storage handler. So the definition like this will actually create the underlying tables corresponding to them. And here actually says okay, the corresponding DB corresponding to this table is actually default, and you can put a table name corresponding to this table and in the underlying DB. Then it will actually query the underlying table from that for that. Okay. So we do a help here. So it has all the options to like look at. You can do all the CRUD, like create, describe, drop, update, and then there are query commands. So query has like execute, explain, kill, and all this. So we'll run some execute. So I'll just open some queries. So the examples come with some sample queries that you can try out. So I'm just printing, see, I'm actually querying product category wise, give me the sales for from 2015 4/11 to like 13 and an hour. Right, so it's actually like 2 days and an hour extra. So because we had only daily updates on DB and no hourly updates, it actually hit Hive HDFS storage, and it will be running this on HDFS. So I'll run a different query. So this is like 12 to 13, which is a full day. That is, yeah. Okay, stationery was the one purchased and has like 39. So I'm running another query with a full day, and this would actually hit the JDBC driver. We'll see where it hit. Yeah. So this is like took 27 seconds. This is like come back in 1 second, because this went to DB where the aggregate fact is available and answered. The other one went to Hive, which had like it has to go through Hive server and a local job runner, which will spawn its own JVMs and then come back. Right? If we actually look at, oops, I had some earlier queries. I hope. I'll just pick the ID from the log, the ones that we have just ran. This is so for the query that was given as cube select, right? So it has rewritten the query as this. It has picked category sales, and it is put the join with my product DB table, and then it has changed the where clause to this with the actual timestamp, and it is grouping by this, and there should be selected driver somewhere. Yeah, selected driver is like JDBC. Right. So if we just sorry for opening the logs here. I'm just trying to figure out the ID. There are like 7 IDs. Okay, okay, this also went to the JDBC. Okay, the other one actually went to Hive, but you can, yeah, we would have seen that here. This also went to JDBC. Okay, that was fine. I'll go ahead with the presentation. Yeah, so that's what is this, and then yeah, so we are the roadmap of the lens looks so far. So immediately we are planning to add submission throttling at drivers. Like right now it directly sits on the underlying driver, and if the driver can't accept, it fails. But we want to introduce throttling so that, like for JDBC, for example, it is configured to say only run 20 concurrent queries at any time. 21st query would fail. And if we have throttling at server level, it can wait or tell the user to stop from there. And then yeah, so currently like there can be only one JDBC driver in the runtime of the server. So we want to add multiple instances, and then add actually support for more streaming source like Elasticsearch and Druid. In the medium term, we want to estimate the actual time that it can take when the user. So there is actually estimate API right now, which is like blank, like it will say 0 and 1. Like Hive, it will say okay, I'll take 1, and 0. JDBC, it will say it as 0. But we want to give times to user so that like he can simply do estimate and figure out which driver it is going to and how much time it is taking. And then the authorization across services, and then add the scheduler service. So scheduled queries I talked about are not yet supported. We'll like to add them soon. And then make it suitable to integrate with BI tools. So though it has JDBC client, we have that cube word in the query, right? So that is something that we'll have to remove. Then I'm thinking that we should be good to integrate with BI tools as well. And then so there is a machine learning library built on top of Spark ML lib. So it is so what is input to the machine learning will be actually a query as output, right? So you can start with the query. So you can give that as input to your ML lib, and then output of the query you can then interactively do drill down and more insights can be inferred. So that is mostly experimental feature that is there in some form right now, but we would like to stabilize that. Long term, we want to add query caching, like if the same query comes, we'll return the result immediately, and then have a Metastore UI where you can actually view all the tables, and an administrator console where you can go actually update his schema and things, and then and give automatic roll-up suggestions on hot data sets through the analytics. And on the exploration, we want to enable Hive driver and Thais and Spark. And then there's Zeppelin, which can be used for the web front end. So that is one more task we are exploring, and we are trying to add like Elasticsearch driver and Druid driver. So yeah, so if you are thinking to solve similar problem, this is already in Apache, it's in incubation. You can go look at the website, there is documentation there, you can improve the doc more. And then so right now it depends on a forked version of Hive, which is posted on GitHub here. We'll be moving to Apache Hive soon. It is on 0.13 plus version. And yeah, so the dev and user mailing lists are open. Your questions? Yes. To the driver, yes. So it will write the query. So you have seen the rewritten query, right, in the query details. So it would have taken the cube query, it would have figured out what is the actual candidate fact which will answer the query, and then write the query, and none of the execution engines need to know cube. So it will figure out the proper physical table and write the query. Doesn't store any data. Data is down there. So since the driver API is like pluggable, the new driver can be added like Phoenix or Spark SQL, which is more SQL-ish, right? So that can be easily added, and experimentation is very easy. Yeah, you can't define it on a UI, but there is like simple UI where you can browse it. So this UI gives like what are all the cubes available, what are all the dimensions available. It will also give the native tables that are there. Like we can go browse it and launch a query from here and submit it, and the results will be shown here. It's like very simple UI. Yeah, some form of it. Only viewing part is there, not the editing. Yes. That is one of the things in roadmap that I have put. So Kylin also wants to define OLAP cube, but they are not unifying the stores though. So the unifying stores is what something Lens is doing. So there are some differences, but yeah, both of them are happening in parallel. Yeah, so there are some differences and some similarities. The only similarity that I'll see is the OLAP cube definition in their system as well. The others are like there is no unification across stores, and Kylin actually builds the cube and materializes it and keeps it in HBase and answers the queries from there. So Lens doesn't actually touch the data right now. It doesn't look at the data. It's only the underlying execution engines that look, and it only gives a single interface for your queries. Yes. Yeah. Good. Any more questions?
One question. So the two queries you have got went double, right? One went to Hive, one went to VDS.
Yeah.
So is it based on the data that is stored on metadata?
Yes. So we have. I have run the query which is spanning a daily and hour, right? So what the data kept on HDFS was both daily and hourly updates were there, and on DB there were only daily updates. So it figured out hourly updates are not there, and when I populated the partitions, anyway I can't populate hourly in DB because there is only daily updates. So the hourly is also populated there. It would pick that fact as the candidate fact for answering the query when an hourly time range comes.
So can you do something where, based on the source any system, say my Hive is busy, can I go to the database?
Yes, so and it's not just the date range that is queried. So the columns, so you might keep more fields in your on HDFS and but less fields in JDBC. Was that your question? Can you?
Say, I have the same data in two places, but can it also look at the system is busy and it is the system?
Busy.
Yeah.
Okay. So right now it will call the estimate. So there are two levels for deciding the driver. So first it will do an estimate on the driver, and if driver says okay I can accept, it will give it to it, and if it is cheaper it will give it to it. So right now like JDBC is like cheaper and Hive is costly. If both of them say I can answer, then it will go to JDBC. If only like JDBC doesn't say, then it will go here. So whenever it is like busy, estimate would actually start saying no I can't take it, then it will go to Hive. No, user has to run it. No, no, there is no federation.
Have you used green thumb or Teradata around time?
And we haven't tried, but if it supports SteadyBC, it should work. No, actually it is pushed through Falcon. The data ingestion is happening through Falcon, at least at InMobi, but data ingestion is not related to Lens. Lens is only querying the data. The only ingestion that is required is whenever data is available, you will have to register that the data is available for this time. Yes, so that is independent problem that has to be solved, but users are not, so they are going to single system and not going to two systems. Yes.